so glad to be on the Brain Mapping TV. Have been involved with the Brain Mapping and Therapeutics group for the past 9 years. Babak Kateb had brought me into this group because it's a collaborative effort between neurosurgeons, neuroscientists, and engineers. I'm a neuroscientist and an optometrist because I do clinical research. Years ago, I discovered that putting glasses on people altered auditory function. So different eyeglasses made people listen better. And since that time, I have worked with Jo Ann Verhoog, who's here. She's using piano as a means to change brain function. And I have met Elliot, who's an artificial intelligence professor in Chicago, Illinois, who works with visual spatial constructs. I've met Cavin, Balaster, who works with integration of vestibular, visual, and cognitive and nutritional components. Cavin is a brain injury survivor. We'll talk later. And this is Amy Pruszenski, who is another optometrist in New Hampshire. And she found that when she started using eyeglasses that changed listening ability, her patients got better faster.
As a professor of artificial intelligence and also cognitive science at DePaul, I know and have come to learn over 30 years of research that the brain is primarily a visual spatial processing device. And if we think about this magnificent device, this computational device in our heads, we have something that's roughly equivalent to 50 million desktop computers. And more than half of that is devoted to visual processing and spatial processing. So from a professional point of view, I know that if we want to reconfigure brains, such as, for example, from brain injury, as Cavin and myself lived through for many, many years, then we are going to have to approach that from using this visual spatial techniques to reconfigure the brain. On a personal level, I lived with this rather horrific brain injury for almost a decade and was told over and over again, Elliot, you will never recover because no one ever recovers from this kind of injury. And we have more than 6 million people in the United States living in that condition. And yet I was fortunate enough to meet Debbie Zelinski here and her colleague Donnelly Marcus. And within really just within a month of having my brain reconfigured using about 1 million input receptors coming through our retinas, she was able to bring me back to life. So once again, thank you for that.
You're welcome, Clark. The one thing that people don't realize is that the eye itself is a piece of brain tissue. So if the brain were made out of clay and you took a chunk in your hand and pulled it forward, that is your retina, the inside of the eye. And when we put eyeglasses on, we're changing retinal chemistry, which changes the whole nervous system and internal things in the body. And the layperson doesn't typically think that glasses change internal functions. They only think that glasses change external eyesight. But so many people after brain injury or people with neurodegenerative diseases have problems internally, and their glasses are fine, they see fine, but they don't realize that a different pair of glasses would make them feel more comfortable. So we prescribe glasses for the side of the vision rather than the eyesight centrally.
Dr. Zelinski, if I might add to that, for many of my patients, many eye doctors use lenses as a tool to get the image clear on the back of the eye. And I like to explain it to patients this way, that we have a what visual system, which most of us are familiar with, but there is a where visual system, which is what we're getting at more with the lenses and prisms and tints and occluders that Dr. Zelinski has discovered is very effective in helping the brain rehabilitate. And I've had so much wonderful success with patients, not always getting them back to pre-injury status, but certainly giving them back as much as we can in the way of function and comfort. So again, I also thank Dr. Zelinski for her work, and I'm excited to be here on the Brain Mapping TV program, helping people understand the collaboration that is needed between clinicians who are working with the patients and the neuroscientists who are giving us the science that backs up what we're doing and finding successful.
Absolutely, and taking that from a brain injury survivor's perspective, first of all, understanding that one half of our cranial nerves, which is like the highway that takes in information and that sends out information to our body, one half of that directly innervate the visual system. And then 1/3 or 4 out of the 12 cranial nerves are dedicated to the visual system. So Dr. Zelinski was talking about the neurochemical aspect of this, and this is the electrical aspect of it. We have our outputs going to the eyeball, 1/3 to these two little peepers, and understanding that what we do visually to rehabilitate can affect everything in our bodies, autonomic function, vestibular function, and so many other ways that we can rehabilitate and make true neuroplastic changes through visual therapy.
Cavin has done an incredible job of writing a book called How to Feed a Brain after a brain injury, and his whole concept of feedabrain.com is fantastic because it's one aspect. If you give your body the right nutrition, your visual system changes. There's a peripheral system, the side vision, and the center eyesight. And the peripheral eyesight shrinks and expands depending on how comfortable your body is. So the more you work with Cavin's book, Feed a Brain, the more your peripheral eyesight expands. And the bigger it is, the better your balance is when you're walking, the better you're not as anxious because you're aware of things coming. The larger your spatial perception is, which works with what Clark does with artificial intelligence. And Jo Ann has worked with posture linked with the eyesight and auditory function.
Right. I started as a classical pianist, had a music school, worked with the very gifted and the challenged, and then started altering what we were doing. I made 13 changes to music so that the visually challenged could read it, and to my surprise, the gifted learned 3 times faster with half the practice because of those visual changes. Over the years, I was amazed and surprised that our students' parents would come in and say their test scores had improved, that they were enjoying things they had never done before. Our adults were talking about promotions, and the turning of changing from music and dropping the piano to just neuroscience was when Dr. Shepard referred one of his colleagues who had sustained brain damage after surgery and was on permanent disability. And in 1 year and 9 months, I had him back to work. And then Dr. Zelinski and Dr. Marcus referred an autistic child who was 6 months into kindergarten and only knew half of his letters and no words. And in a year and 9 months, he also, besides visual, he had a list of 10 things. He couldn't walk leg to leg in place. He couldn't sit on a piano bench without being supported. Couldn't hold a ball. And in a year and 9 months, he was passed on to first grade. After 4 months, he knew 200 words and was on a baseball team. And so what I learned from this was that in using the physical, the auditory, the conceptual, and the cognitive neural pathways in the body, I could identify which were strong and which were weak. And then I pair 2, 3, 4, 5 strong neural pathway elements with a weak visual neural pathway element and continue testing. The students and adults do 15 to 30 minute exercises 4 times a week, and every 6 weeks we retest, and when we see anything that has moved from a very uncomfortable to uncomfortable or uncomfortable to comfortable, we know we're strengthening those pathways, and that process continues. And whatever the physical elements I've worked with, another group are people who have had a stroke and haven't read for 7 to 10 years, even though they've been in the traditional therapies. They are reading, and the auditory of those who can't speak after the stroke have also moved to being able to speak. And the fun part of this is for the speech, what I've done is worked with visualization until they can see a sentence of what they want to say, and then they just read it. And by doing that, after practice, they're able to have a social life again.
That's the whole interesting thing about brain function and brain mapping TV, is that your brain is plastic and it changes. So Jo Ann is building up weak pathways by pulling them along, linking them with the strong ones. Cavin lived through that as a brain injury survivor, having to learn how to walk all over again.
I have comments on a couple of things. First, Amy, you said we don't always get all the way back, but sometimes we do.
Sometimes we do.
Just to make this a little bit personal, that Cavin and I are like Lazarus risen from the dead. If you were to see me 4 or 5 years ago, you'd find a man who, after just sitting on a panel like this, I would have to sit down in this room for an hour before I could walk, and I'd be holding on to the walls just to get out of the room. I couldn't understand what people were saying to me. This is so common from brain injury. People write to me from all over the world that we don't understand the world anymore. We don't understand where the ends of our bodies are and the rest of the world begins. We don't understand jokes. We can't listen to the radio and make any sense of this. But in my case, through this magic of brain plasticity, where we take a brain, we find the parts of the brain that are not healthy anymore, and we route channels through the brain through healthy brain tissue, and that part of the brain will take over functioning. So I am now fully recovered in all ways. I am ready to get on with the rest of my life. And I lived that way for almost a decade before coming just accidentally, almost stumbling across these brain plasticity techniques that are so very, very powerful. So if I had a comment, it would be a desperate plea for these neurodevelopmental optometric techniques that use the retina to reconfigure the brain, for that word to get out, that so many of these people, not only around the United States, but around the world, that are suffering from the lifelong, or we would think lifelong effects of these terrible injuries, that they can get better, the same as I did. There's no actual magic in the science is real. And I have a comment, you talked about hearing, the link between hearing and visual processing. And this kind of makes the point about how dynamic the visual processing in the brain and how it's at the core of what makes us human. I'll give you an example. If I reach out behind you and I tap a wine glass, just hearing that glass ring, instantly you're seeing that it's a glass. You might be imagining, and that's visual, yes? And it's spatial because you know it's behind your right shoulder, it's not behind your left knee. You'll see the color red if you're imagining red wine, or yellow if it's a white wine. You might be seeing a sequence of time where there's less than and greater than, reaching back into last week to say, I had some wine with my friends last week, and you recall what you talked about, and you see the image of their faces. And all of this is visual, spatial processing, and that came from just the sound of my tapping the wine glass. So we think we hear with our ears, and we think that we, smell the world with our noses, but that actually is not accurate. Our brains are visual, spatial processors down to the very core of what makes us human. So thank you once again, Debbie. This is what I recorded in this book, The Ghost in My Brain, is coming back to life and once again being a human being again.
Well, and I'd like to speak to that, where I am a trained optometrist. I've been in practice over 20 years, and I read the book, thank you, and realized that Dr. Zelinski was able to do things that I had not been taught to do. So I have many patients who have been to 3 and 4 and 5 different eye doctors, for example, and or other doctors, and they're told they're fine, and the patient knows they're not fine. They're on the floor unable to function, but they are able to read an eye chart, for example. And I want to be clear for our audience that any optometrist might not be trained in this aspect of things, just like you might go to an ophthalmologist who's trained in retina, or you might have a different ophthalmologist trained in glaucoma. There are different areas where we have extra training, where we understand this eye-brain-body connection. And I do feel passionate working toward having all optometrists at least have a basic understanding of this, so they can at least be screening for these problems and then sending on to optometrists who do this kind of work. So please don't be frustrated if you are a patient who's been told your eyes are fine. Your eyes are probably fine. It may be that the part of your brain that's processing the vision and trying to integrate with your other senses that might be having the problem, and there is help to be had. So again, I think it's a team effort here where we're trying to get the word out and help others get the help they need.
We have a campaign called Leave 2020 in the 20th Century.
Yes.
And actually starting in a few weeks, there'll be 20 months left until 2020. So we have 20 months to get the concept of 2020 should be in the 20th century put behind us. Because so many people come in and they are 2020 and they say, well, therefore I don't need glasses. And they don't realize that 2020 concept was invented in the mid-1800s. It's more than 150 years old. And when it was invented, it was the best thing ever to standardize eye care. But that's how optometrists are taught that, make the patient 20/20. But don't make them comfortable, make them 20/20. And that goes back to what you said, Amy, with the what is it system. If you sit and you cover one eye and you look at a letter and say, yes, I can see it, and which is better, one or two? This one is clearer? Oh, great, that's your glasses. But that clearer glass might mess up your auditory function. You might not be able to listen as well, or it might twist your posture.
Keep in mind that you're thinking, I can't hear very well, or I seem to have attention disorder. I can't study my physics,
Balance issues.
I have balance issues, or my back hurts, and you don't realize, because nobody's ever brought this concept out into the modern world, that this is a problem with your retinal processing.
Well, they have. It's been since the 1920s. It's been brought out, but there wasn't research backing it up. Now the research is backing it up. So and the fact that Babak Kateb has put together such a nice brain mapping and therapeutics organization is fantastic, because it allows us to use retinal neuromodulation to alter what's going on in the body. It's
And you should mention this non-visual retinal processing. This is a wild part.
that there's a part of the eye that doesn't have anything to do with eyesight, that it has to do with the chemistry in your body or the posture. So when light hits your eye, some of it is used for eyesight, but some of it has nothing to do with eyesight. And the closing example that I use a lot is a mouse running across the room. That if you have a mouse running across the room, all it does for your sensory input is make a little shadow on your eye. Yet what it does to your body, it'll increase adrenaline, it'll tense up your muscles, it changes your thinking. So just a little shadow on the edge of your eye can do that to your body. A brain injured patient has this happen all the time when anything moves, and it's hard for them to go in grocery stores or anything else. Did anybody have any closing statements?
First of all, I appreciate the rising from the dead kind of I'm often asked, how long did it take before you were 100% recovered? And I say 100%. I'm like, QX4W9% recovered, it's a whole different scale, So, but the point is, how did we go from where we were to where we are? And I think figuring out these pathways is one thing that's extremely important. And I love that we're bringing together so many different modalities to solve these problems and to find ways to optimize recovery. The other aspect that I often talk about is motivation. And this is where I love what you're doing, where you pair the strengths with the weaknesses and they just bring them along for the ride. Because when you're working on nothing but the weaknesses, it gets a little depressing, I am so happy to be on this panel. I appreciate you guys so much, and probably had more to say.
Thank you, Cavin Balaster from feedabrain.com. Thank you, Jo Ann Verhoog from the Verhoog Neuroscience Institute. You had something to say, Amy?
I just wanted to say a final word. I'm grateful to Dr. Kateb for the Society for Brain Mapping and Therapeutics, because one of the biggest barriers, and their goal is to break down barriers, is there's no research. Well, the research is there, first of all. It's just people aren't reading it or paying attention to it. And now we have a direct group that we can work with in team, in collaboration, to have the research we need to back up what's been working in clinic, and we can help more patients that way. So I'm very, very grateful to this organization, and I'm glad that you're hearing this, and hopefully this will help change some lives.
And thank you, Amy Pruszenski, an optometrist from New Hampshire. And thanks to Clark Elliot, the author of The Ghost in My Brain. And this has been a really nice panel to show how everything works together. And as you said, the research is there. It's just in the neuroscience journals. And to bridge the gap from the neuroscience research into eye care is a big leap. And Babak Kateb is championing he's pioneering, championing the cause.
Well,
and
I also,
from neuroscience into the emergency room.
Yes.
Yes.
And into the halls of academia.
We have the screening.
important.
There's people who will be screening eye-ear connections because it's so important, and it's detrimental in brain injuries. There's a disconnect. So the brain mapping TV is able to get to the layperson and show how the different disciplines are working together. It's a great opportunity. Thank you.